Hello students, this is a video lecture covering section 8.5, vectors. By the end of this unit you'll be able to describe vectors and use them to solve problems. So let's start with some vocabulary. A vector is any quantity that has both magnitude and direction. In geometry, vectors are represented by rays, where the endpoint is called the initial point, and the tip of the arrow of the ray is the terminal point. The magnitude represents the length of the ray. Oftentimes we use ordered pairs to describe a vector. The magnitude and direction are determined to the point from the origin. A few examples of where we use vectors in real life include magnetic fields and gravity. So first, let's work a problem that asks us to describe a vector as an ordered pair. So here we have vector OL, and we're asked to round the coordinates to the nearest tenth. Since vectors are often thought of as coordinate pairs, we use this angle, the angle created by the vector with the x-axis, and the magnitude, or the length of the vector, in order to find the lengths of x and y. So if we use this angle, the 50-degree angle, as a reference angle, and the hypotenuse, we can use both sine and cosine to find the lengths of x and y. So we have sine of 50. And as we remember, sine is opposite over hypotenuse, or y over 65. So to find the length of y, we say that this is 65 times the sine of 50. So we plug this into our calculator, and we find that y is about 49.8 units. On the other side, if we use cosine of 50, we find that cosine is the adjacent side x divided by the hypotenuse of 65. And again here, x can be given as 65 times the cosine of 50. And so we plug this into our calculator and we find that x is about 41.8 units. So we want to write OL as an ordered pair. We're going to want to use the special brackets. We want the x coordinate. So since x is going to the right, we use the positive value, so 41.8 for our x. And since our y, the length of y is 49.8. But since it is below the x-axis, we want to use the negative value, so negative 49.8. And close those brackets. So let's try another question of that same type. So here, our reference angle is going to be the 10-degree angle. It's not labeled for us, but we can say this is the length of x and this is the length of y. So if we use cosine, we'll find the length of x. Cosine of 10 degrees equals the adjacent side x divided by the length of the hypotenuse, which is 312. So again, to get x all by itself, we multiply both sides by 312. So we have 312 times the cosine of 10 degrees. And if we plug this into our calculator, we find that x is about 307.3. To find y here, we use sine. So we have sine of 10 degrees is going to equal the length of y divided by 312. So y is going to equal 312 times the sine of 10 degrees. And if we plug that into our calculator, we get that y equals about 54.2. Here, vector OL points both left and down. So both of our coordinates are going to be negative. So we have the negative x value, or negative 307.3. And since it goes below the x-axis, we want the negative value, negative 54.2. So these are the coordinates of vector OL. Oftentimes we use compass directions to describe vectors. It's really handy to know what we're talking about when we're using compass directions. So the first thing that we do is we write the actual degree angle. So it's 25 degrees. We describe the direction it's headed from the base direction that it started. So this leftmost picture is 25 degrees south of east. The easiest way I can tell you to remember this is the second one is the one that it's closest to. And the first letter is the one that it's headed towards. The only time this gets tricky is if it's a 45-degree angle, because then it'll be directly between two of them. But as many of you know, if it's exactly 45 degrees, then typically we use one of the other four identifiers: northeast, southeast, northwest, or southwest. So for this second problem, I would say that this is 35-degree angle. It's headed towards east, but it's closest to north. So this is 35 degrees east of north. Now occasionally we get problems that we can't do in this way. For instance, if we tried this one, we would say that this is 60 degrees. The one that it's headed towards is it's headed towards south. So this we would say is 60 degrees south of west. However, this is not the best way to write this one. Now we know that each angle within the west-south is one of a complement pair. So 60 plus 30 gives us the 90-degree angle. So I personally would say that this is 30 degrees west of south. Technically either of these is correct. However, oftentimes we like to have this degree measure less than 45 degrees. Okay, so our third type of problem asks us to find both the magnitude and direction of a vector. So we start with an airplane, and it lands 246 miles east and 76 miles north from where it took off. So let's start with some kind of starting point. And from the starting point we go 246 miles east and 76 miles north. So we are 246 miles east and 76 miles north. So this is the actual vector that we're looking at. So section 8.5 is kind of the culmination of a bunch of different things. The first thing that we need to do is find the magnitude. Since east and north meet at a 90-degree angle, we can include that in our diagram. Because this is a right triangle, we can find the magnitude by using the Pythagorean theorem. So in this case, we know that c squared has to equal 76 squared plus 246 squared. So here, c squared equals 5,776 plus 60,516. So this gives us a total of 66,292. And if we take the square root, we get that c is about 257.5 miles. Now, to find the direction, we need an angle measure. For that, we're going to have to use trig. A lot of people make the mistake of using this length in their trig function. Unfortunately, that's not a precise measure. So what we want to use is the 76 and the 246. If we're trying to find this angle, that gives us the opposite and the adjacent. So we have the tangent of x degrees is going to equal 76 divided by 246. So x is then going to equal the tangent inverse of 76 over 246. And so x to the nearest degree is about 17 degrees. So the vector here that we're talking about has a magnitude of 257.5 miles approximately. And I would say that it is 17 degrees north of east. So here we have a new vocabulary word, a resultant. And a resultant is given as the sum of two other vectors. So in this case, we have a plane traveler. They're going from Albuquerque to Salt Lake City but they have a flight that stops off in Flagstaff first. So they do two things. They combine vector u with vector v, but the end result of their travel still ends up being that they go from Albuquerque to Salt Lake City. So the resultant vector here is vector w. And so this leads us to a property. So if we have two vectors, vector A and vector C, given by coordinates x1, y1 and x2, y2, and we want to add those two vectors together. The sum of vector A and vector C is given by the sum of the x coordinates and the sum of the y coordinates. So here we're asked to add two vectors together. So the first thing we want to do is define the two vectors. So we have vector A, which is going to be given as an ordered pair. So we have -1, 2, 3, 4, -1, 2, 3. So this is -4, -3. And we have vector C. So vector C is 1, -2. So as an ordered pair, we want to take the -4 plus 1, which will give us -3. And -3 minus 2 gives us -5. So in this case, the resultant vector is the vector that starts at the origin and goes to -3, -5. Our final question today asks us to put it all together. So we have a friend that invites us to go boating on a river. The speed of the boat is 35 miles per hour in still water. The river is flowing directly south at 8 miles per hour. If the boat goes directly west, what are the boat's approximate resultant speed and direction? So here we have to find the length of the magnitude c, and to describe the direction we need to find the value of x. Let's start by using the tangent function to find the value of x. So the tangent of x equals the opposite, or 8, divided by the adjacent side, which is 35. So the value of x is going to be given as the inverse tangent, remember we use inverses when finding angles, of 8 over 35. And that's going to give us an approximate value of 12.8 degrees. Now to find c squared, we know that c squared equals 8 squared plus 35 squared. 8 squared is 64. 35 squared is 1225. So the total here is 1289. And so c is approximately 35.9 miles per hour. This boat will travel approximately 35.9 miles per hour at 12.8 degrees south of west. And so that concludes this video lecture on section 8.5, vectors. Hopefully you're now able to describe vectors and use them to solve problems. Thank you very much for your attention, and I'll see you soon.